Alright, next in the factoring series is going to be factoring high-level polynomials. High-level polynomials include anything just above a quadratic, so like a cubic, which is like x to the third and then something behind it, or x to the fourth plus or minus or whatever. So a quadratic is a polynomial, and often the most simplest that you will find. But we already covered factoring quadratics, so now we've graduated to factoring polynomials. Now, factoring polynomials can seem a little scary at first, but if we were to see something like x to the fourth minus 5x cubed plus x squared plus 21x minus 18. How in the world do we begin with that? We can begin somewhere quite simple. We can either... What we do first is we put this into a graphing calculator and see what that pulls and see what that gives us as any, see if we can find any, any decent zeros. So I have the equation plugged up here in Desmos, and we get as a zero, we'll pick any of these that look, relatively normal, which it appears all of them do. So we'll only use one of these, but this would be a pretty easy one to just recognize and see that these are the zeros of the equation. But if we didn't, let's say these two weren't like regular zeros, then what we could do is look at this and say, oh, so x plus 2 is a factor of it, because minus 2, you just switch the sign and that gives you your equation, because if you want x plus 2 to equal 0, you have to set x to negative 2. So that's why if you have negative 2 as a 0, it's x plus 2. And that goes for anything, just switch the sign. So, working from that, we get x plus 2 times something equals this. Now, how do we do that? What we do is we take our 0 that we got from this, which in this case is negative 2, and we set it up in something called synthetic division. Synthetic division is this little box right here where we put our 0 on the outside like this, and then we take our coefficients of all of these and put them in a row here. So we have 1, negative 5, 1, 21, and negative 18. And then what we do is we bring the first one down and we get 1, and then we multiply the negative 2 by this to get, negative 2. Negative 2 times, or negative 2, and then we add these two together to get negative 7, and then we multiply the negative 7 by the 2, and then we get positive 14. Positive 14. Add the two together, and then we get positive 15. And then multiply the negative 2 by the 15. We get negative 30. Bring those two down, add them together, we get negative 9. And then multiply the negative 9 by the negative 2, and we get positive 18. And then positive 18 minus 18 is 0, which means these are now the coefficients of our new equation. So what we do is we take 1, bring that one, x cubed. Oh goodness, that's horrible. It looks like plus 1x cubed, and then minus 7 x squared plus 15 x, and then minus 9. And then we don't do anything with the 0. So this is our new equation. Now what we can do is plug that into our calculator. It was, what was it, x cubed minus 7x plus 15, and then minus 9. Minus 7x squared plus 15x minus 9. Now we pick another 0, in this case 1, and do the same thing. So we do our synthetic division with 1 this time. Then we have 1, negative 7, 15, and negative 9. Now what we do, just like before, bring the first one down, 1, and then put the 1 there. Well, multiply the 2, and then put the result there, which in this case is just 1, so we get negative 6. And then take negative 6 times 1, negative 6, which this will give us, positive 9. And then, from there, we take that, multiply again, and we get positive 9, and then we end up getting 0. So those zeros can be ignored because that means it factored out completely. So now we have 1x squared minus 6x plus 9. Now, this is actually a perfect square equation of x minus 3. So x minus 3 squared equals that. Now, to recognize that, what we can do is notice that this is 2 times 3, and this is 3 squared. So, and then the negative sign means that this will be negative. So recognizing that, when this last term squared, or when the square root of the last term is equal to half of the middle coefficient, then you have a perfect square equation. So, after that, after all that synthetic division, we'll bring u up. We will bring our x minus 1 from this over, and we will bring u over to get x minus 1 times x minus 3 squared times x plus 2. And then that is the fully factored form of this equation up here. Pretty simplistic once you, again, recognize the patterns, recognize which equations would be perfect squares, learn how to easily recognize zeros when graphing, and if we actually plug in our original equation and then plug in our new x minus 3 squared times x minus 1 times x plus 2, we can see that they match. Look at that. Pretty darn perfect. Which means these equations are in fact the same, and this is the factored form of this. So, again, pattern recognition and knowing how to do this synthetic division. Synthetic division, it sounds scary, but it's pretty easy. Just remember, have your first term, or have all of these inside terms be the coefficients of those, and then have this outside term be the 0 that this corresponds with. Other than that, synthetic division, drop the first one, multiply, bring back up, add, drop, multiply, add, drop, multiply, add, drop, multiply. It's just the same thing over and over again. And that is how you factor a polynomial. Graph it, synthetic division, and then you can use the quadratic formula if needed, especially on this last bit here. Most of the time it won't work out this well of being a perfect square, but quadratic equation, x equals negative b plus or minus the square root of b squared, of b squared minus 4ac all over 2a. Pretty well known if you're past algebra 1. But yeah, happy studying, thanks for stopping by, and goodbye.